Good morning, good afternoon, and good evening, depending on where you're joining us from, and welcome to today's webinar, Meeting Consumer Demands with Smarter Manufacturing. My name is Casey Flanagan. I'm an associate editor with PMMI Media Group, and I will be moderating today's webinar. We have a great program planned for you, but before we begin, we have to tell you about the industry's next event, Pack Expo East 2026 in Philadelphia. It's where East Coast packaging and processing professionals jumpstart projects, discover what's new, and accelerate research. With 500 exhibitors, you can explore a wide range of solutions and plenty of machinery in action. New this year, Pack Expo East will debut the Containers and Materials Pavilion, showcasing innovative packaging solutions with glass, paperboard, sustainable and eco-friendly options, and more. Pack Expo East is happening February 17th to the 19th at the Pennsylvania Convention Center in Philadelphia. As a webinar participant, you can register for free at packexpoeast.com with the comp code webinar. Now, a few housekeeping items. On the right-hand side of your screen, you'll see the chat section. This is where you can share your thoughts and connect with other attendees throughout the session. Keep in mind that all comments shared here are public. Feel free to jump in there now and let us know where you're joining from. We'll also be keeping an eye on the chat for questions for our speakers. You can post them at any time, and we'll answer as many as we can during the Q&A period at the end. Any we don't get to will be passed along to to our speakers for follow-up afterward. After today's event, you'll receive a follow-up email with a short survey. We'd love your feedback. And you'll also receive a link to watch the on-demand recording once it's available. If our speakers or sponsors have shared any extra materials, you can find them in the handout section located just below the video window. Now, on to today's webinar. Today, we'll explore how evolving consumer expectations are reshaping manufacturing with a focus on packaging innovation and automation. Kuka robotics experts will demonstrate how robotics, AI, and digital simulation tools drive efficiency, address labor challenges, and improve ROI. The session will also highlight Kuka's iiQKA ecosystem and software solutions that simplify automation and enhance competitiveness. And now it's my pleasure to introduce today's speakers. First, we have Chad Ducart, Key Technology Manager for Food and Beverage and Consumer Goods at Kuka. Chad is an applications expert at Kuka Robotics with an extensive experience in picking, packaging, and palletizing solutions, including Kuka Pallet Tech, Kuka Pit Control, Kuka FlexPal, simulation, and conveyor technologies. He currently supports integrators on palletizing applications with custom grippers, leveraging Kuka products and customer-specific KRL applications. We also have Rich Parkhurst, Business Development Manager for Consumer Goods at Kuka. Rich is a business development manager at Kuka Robotics Corporation, where he leads growth initiatives across North America in the consumer goods sector, including food and beverage, personal care, pharmaceutical, and logistics. With over 25 years of experience in industrial automation, Rich brings a unique blend of engineering expertise and strategic insight to the evolving landscape of smart manufacturing. I know you'll enjoy today's presentation, and I'm excited to get things started. So with that, Rich, the floor is now yours.
Hello, everyone. Thanks a lot, Casey, for the introduction. Yeah, so today we want to go ahead and talk about some of the things that we're seeing in the market with regards to opportunities, and then also some of the challenges, and discuss some of the things that Kuka is doing from a technology perspective to help with some of those trends and challenges that we see. So just to kind of go through the agenda here. So I want to first of all intro Kuka in case you don't know who we are and what we do. And then also talk about the packaging market trends that we see, the impact on manufacturing that can have, and then the role of Kuka in that transformation when it comes to the technologies that are implemented in these manufacturing processes. And then finally, we'll do some recap and wrap up and give some time for Q&A. So as a quick background with Kuka, a lot of things that the people that don't know about Kuka is that that name is actually an acronym. It stands for Mr. Keller and Mr. Nappich. So it's Keller und Nappich from Augsburg. That is what the Kuka name stands for, and we go back 157 years to 1898 when we weren't even thinking about robotics, right? So a lot of technology advancements. The first electric 6-axis robot that came out in 1973, and then technology has progressed since then. Another kind of key point in time for Kuka was we were the first to market with the PC-based robotic controller, and then now we've also added the AMRs to our portfolio, and here we go, as we'll talk about later, with new operating systems for the robot controllers and AI-based technologies, and we'll get to all that information. So we consider fast-moving consumer goods a major sector of focus for Kuka. What we mean by that from an industry perspective is we're talking about food and beverage, we're talking about personal care, we're talking about pharmaceutical, general logistics, and material handling. So when we talk about consumer goods, we're covering all those spaces within industry. When we talk about kind of where we implement Kuka robotics technologies, it's really throughout the value chain. It's throughout the manufacturing process. So from the incoming raw materials to the handling of those materials through the process. So these could be 6-axis robots, they could be SCARAs, it could be Deltas, and then finally, again, the most recent technology that we've introduced has been the AMR, the autonomous mobile robot capabilities in our portfolio. So let's talk about what's really important to the industry here. Let's talk about, when we talk about consumer goods packaging, trends and challenges, what are we seeing from a robotic manufacturer's perspective? So the first thing is we're seeing sustainable material and circular packaging. So a good example of this is I was recently at a DHL Innovation Center here in the U.S., and they were actually using packaging for shipping products that would get reused. So the way that would work is the shipper packages into this nylon package that would get shipped via the normal process, and then at the end user, they would, or the receiver, they would take those products out of the package and return that packaging to DHL for reuse later. So we see a lot of that. We see a lot of the sustainable packaging with using paper type products instead of plastics, things like that. So that is definitely a trend that we see with regards to packaging itself. The packaging materials itself is we want to be more sustainable. We want to see the greener supply chains. And Kuka is actually running an innovation award competition right now on this topic. That will culminate at Interpack in 2026 in Europe. So I believe they just got done with the initial phase of submissions for that. And then the best circular packaging concept will be selected at Interpack, and there will be a monetary award, and typically these are for startups. Smart and connected packaging is another area that we see a lot of progress when it comes to the changing in the packaging itself. So we've seen for a long time the QR code implementation to be able to track packages and things like that. What is their status? But we're seeing even more. We're seeing RFID tags embedded. We're seeing GPS information embedded, temperature, shock and vibration information, because sometimes the things that are contained inside of this packaging are very important. It's expensive. It could be fragile, and so the shipper needs to know where that item has been, what kind of temperatures it's seen, what kind of shock and vibration it's seen, and so we're now embedding those sensors into the packaging. Another good example is back to that DHL example, is in those same reusable containers, they can also put monitoring devices so that in real time, the shippers and the receivers can see what has happened with that particular shipment. A good example of that was during COVID-19, and even today, as we ship these vaccines, where you have to have specific temperatures maintained for the vaccine itself, we can actually monitor that information and then guarantee the quality at its endpoint. And then finally, this is a bit obvious, but I'm just going to put it out there. Automation and flexibility in packaging is very, very important. So we need the ability to leverage a system to be able to do fast changeovers. We need to be able to do have a modular approach to the packaging system, and then we need to be able to quickly change, because everything's not very large batch running the same product over and over and over again. We need to do things where, I think about a case packing machine that I just recently saw at a show. One case packing system can handle multiple size cases. The tooling can change out on the robot to be able to handle different sizes of bottles. So maybe you're handling 1 gallon today, but you're handling 1 quart size tomorrow. Obviously, the case package changes, the robotic tooling changes, but that changeover can happen very, very fast. So we need to have that flexibility, and what we see is, typically mechanical based hard automation, there's a little bit more involved with the changeover, whereas we see a lot more flexibility in the world of robotics when it comes to those changeovers. Kind of continuing on with the case for robotics, what are we trying to achieve? We want to be more efficient, and in a lot of cases, it happens to be that a robot can handle the application faster than typically a human can. We also want to make things safe. So repetitive tasks, heavy lifting, the things that can be somewhat dangerous long term to humans, that definitely lends into the robotic discussion. Flexibility, quick changeovers, being able to change programs for different products very quickly, that just lends itself to the robotic solution. And then finally, labor. I hear labor talked about a lot, but it's really different depending on the industry, the geography, and kind of what you're dealing with. That labor discussion tends to change. So, are we dealing with a cost of labor situation? Are we dealing with a safety of labor? Reliability of labor? I hear all these messages differently, again, in different industries and different geographies. But it all kind of comes back to the idea of, if we can automate, it absolutely makes sense to help with the labor risk, and we'll talk about that a little bit later. So the time to automate is now. I don't think people would typically disagree that you need to automate. But what is the return on investment? That's typically a very quick question that comes about when we talk about automating a process. How much am I going to spend versus when am I going to break even on that system versus what I'm doing today? And what I would say is you have to kind of take a step back, because there's more to it than just the simple ROI calculation. When you talk about return on investment, we also need to talk about risk. What is the risk that someone doesn't show up for work tomorrow? What's the risk that someone gets hurt doing that job tomorrow? And those are kind of soft costs that can be a little bit more difficult to calculate, but need to be taken into account as you're having the ROI discussion. One other thing that I see is the sacrifice of quality and support over the hardware cost. And what that ends up being is there's a lot of low cost solutions out there when it comes to automation and robotics. And what you want to make sure of is that the support structure is present and the quality is present in the things that you are using. Because ultimately, if you're missing those two things, you are going to increase your total cost of ownership, which is something we kind of pride ourselves on at Kuka, with regards to keeping that TCO down and keeping your overall reliability and your total keeping your TCO down and reliability up. And then finally, you need to also be sure that you're planning and budgeting for upskilling your workforce. Those individuals today that are doing manual operations in the case packing or palletizing or those types of operations in the manufacturing space, we want to upskill those people to be able to operate and maintain these higher level automation and robotic systems. So have a plan in place. That, we talk about ROI, but let's also talk about risk, and let's talk about upskilling of the existing workforce, because we hear a lot in the industry about, automation, robotics is going to put people out of work. No, we just want to kind of change the dynamic and upskill the workforce for this automated environment. So We see some deployment challenges when it comes to robotics. First of all, it kind of historically we've seen robotics as a specialty. So your typical controls engineer, they know their PLCs and their communications networks, the HMI interaction, but then the robotic handling might be handled by a different individual, and that's because robotics traditionally has had a different programming tool set, a different programming language, just a different subset of knowledge. So we're seeing a need to combine those things. But what we have to do then is we have to make things user friendly to multiple types of teams in that situation. Product changeovers. So, again, in that hard automation situation, what does it take to go from product A to product B? Is it the flip of a switch? Is it reprogramming? We've got to make sure that that is a very efficient changeover so that we can get manufacturing going quickly. Space and layout constraints. A lot of applications are going into brownfield facilities. Not everything is a brand new built facility. So, safety needs to be taken into account with regards to the space that we're taking up. Do we need guarding? Do we need hard guarding? What's involved with that? And then multiple robot sizes and types. Does your complete system, is it handled by a single programming platform? How many programming tools do you need in order to get through that deployment? That becomes a topic of discussion, because you already have multiple manufacturers of technology in your system. You don't want to have multiple pieces of software that you have to manage within a single manufacturer. So how does Kuka help with that, and where are we headed with that discussion? So I guess the first thing that I would point out is first of all, when Kuka approaches a robotic application, we look at it throughout the complete life cycle. So starting with the plan and select phase in the top right here, lots of tools and services offered in order to be able to make sure that you're selecting the correct products and the correct correct payloads, correct reaches, correct cycle times for your application. Again, these are both software tools that are available to you as the user, or also services that can be provided by Kuka and or our system partners. Then you move on to the setup and programming. Again, leverages a lot of the same tools that we used in the planning and selection phase, but now we're going to be using that to actually commission and deploy the robot. I'll show you later on with the new programming software and controller set. A lot of those tools are getting streamlined into a single user interface, so that you can do that plan and select, and then you can do that setup and program, and then also onto the operate and maintain phase with a single tool set. And then finally, upgrade and refurbish. After 10, 15, 20 years of operation, it might be time to upgrade your controller. It might be time to upgrade, both the manipulator and the controller. And so we offer services and capabilities to be able to help you through that process. So from a manufacturer's perspective, having that so-called white glove service from the time that you're considering your robotic journey to the time that maybe it's time to even get to replacement 20 years down the line. Kuka is able to support you through all those steps. So when we talk about the tool sets for the future with regards to robotics and packaging and robotics, we need to make sure that all these tool sets are integrated and scalable. So I talked about one of the challenges being the mix of robots that you have in a facility. Do you have multiple tools that have to be used to program those? And so the idea is, we have to be integrated, and then we also have to have the usability factor, right? We need to be easy. Making automation easy is one of the key lines here, that one of the key points of emphasis for Kuka moving forward with our tools is we need to make the usability there, again, through all 4 phases of that robotic journey. So how are we doing that? Well, we're starting out with a new operating system for the Kuka robots, which is called iiQKA.os2. We are also introducing a new configuration and simulation platform called iiQWorks. And then all of that culminates into a new robotic controller, which is the KRC5-2. So let me dive into some of the details on that. So first of all, on the engineering side, the iiQWorks is where you're going to do your offline programming. You might do some selection information, do some selection within that tool, and then also you're going to be able to run your simulation of your robot as well in the iiQWorks platform. So a programming and simulation combined into a single tool called iiQWorks. Also on the engineering side, you can also have the actual robot operating system installed on your PC. So rather than working in a kind of a quasi simulation environment, you can actually run the operating system on your laptop, on your engineering PC, so that you can get the true cycle times and see the robotic controller in action in real time while you're in the simulation environment. And then finally, there's the hardware side of it. So you've got the new KRC5-2 controller, and then a couple of different options when it comes to the operator interface. So when we look at that, historically in the robotic industry, we've had that big pendant, right? That big heavy duty pendant that hangs on the side of the controller. And we're still going to have that. We're still going to continue to innovate in that environment. But we're also introducing some flexibility there as well. Since the new operating system is web-based from an operator interface perspective, that means that now we can visualize what's happening in the controller, or what would be happening on the operator on the operator pad. We can actually also look at that in a web browser on a PC, or even, as you can see here on the right, you can even see that we're using an Android tablet with the smart plug attachment to be able to do our safety control of the robot. So we have the options of using the traditional pendant, our PC, and or an Android tablet to be able to see what's happening in real time with the robotic controller and the robot itself. So we hear a lot in industry about digitalization, and digitalization is a very broad term that means a lot of things. It could involve IoT technologies. It could involve AR, VR type technologies. But where I want to go with that discussion today is really talking about the use cases for a digital twin. So when we talk about a digital twin, we are talking about a mechanically based visual simulation of the actual machine, the actual cell, the line, the facility, right? We can take that as broad as we'd like when it comes to the digital twin terminology. Now, if you look at the four use cases that I have listed here, planning, selection, design, that's something that the robotic industry has been doing for a long time in their software tools and simulation tools. But where we're taking the next step is into virtual commissioning. So when we decide to move forward with that automated system, that robotic-based system, a lot of times we place our orders for equipment, and we've got a number of weeks, maybe even months before the physical hardware gets delivered to us and we can start programming physically. So what we want to do is we want to leverage virtual commissioning capabilities by using all the high-end simulation tools that we have available to us. And that doesn't just include kind of looking at it from a blinders approach in that, okay, I can simulate the robot, I can simulate the activities of the robot, and that's good enough. Where I want to take that is I even want to have that robotic cell or that line, that machine or that line also interacting with the overall automation system that's going to be handling that complete manufacturing process. So when people think about when they think about digital twins and they think about simulation, they really think about graphics and what's happening on a screen. But we also want to take that to the next step of full virtual commissioning, where we have the automation system, the PLCs, the HMIs, interacting with the robotic controllers and the IO systems so that we can fully program and test the system before we actually have the physical hardware in front of us. And that's going to save us a ton of time once the equipment does show up on the floor and get powered up. The next thing is operator training. again, before the system is actually present for us, we want to be able to show the operators how things are going to look on the machine operator interface. We might want to be able to show them how things are going to look with the robotic control. We can do all that training in the virtual world before they actually get their hands on the actual machine. So, super safe to be able to do it that way before we get people engaged with potentially dangerous equipment, and we just can fully vet out the training process before we actually get on that expensive and potentially dangerous equipment that's going to be operated. And then finally, what's the first thing that happens once the machine gets deployed? Somebody wants to enhance it. Somebody wants to say, hey, what if we did X instead of Y in this operation? Well, by having that full digital twin integrated with the automation system, now we can actually do the change planning and testing in the virtual environment before we take that out to the manufacturing space. So now we decrease the risk, we decrease the implementation time, and just again overall make that a much better and more efficient situation for the deployment of changes in our automation system. AI is also coming to fruition within the robotics world. We're hearing a lot in industry about AI implementation. Whether it be for troubleshooting and maintenance type tasks. But when we talk about the deployment and the programming of robotics, AI is definitely having an impact on the development and future of the software and hardware that we'll be deploying. And so Kuka has two partnerships that have developed in that process. One is with NVIDIA. We hear about NVIDIA a lot in the AI space with regards to their processing capability for AI applications and the programming tool sets that they've made available. So we are partnered tightly with NVIDIA. The new KRC5-2 controller will have an option board that's going to have the Jetson chip implemented in it. And so we're gonna see everything from internal capabilities of processing vision applications all the way to third-party development capabilities within that Jetson chip and the NVIDIA environment for running a Kuka robot. The other area that we're partnering is with Microsoft on the Copilot functionality. We're hearing a lot about Copilots on office-based tools and being able to help you write emails and things like that. But where we're looking at that is, for somebody that doesn't know how to write code in Kuka robot language, which is the kind of the language that our robot controllers speak from a programming perspective, what if somebody was able to actually just type in English language, or in any language for that matter, just in layman's terms, what they want the robot to do, and then have the system be able to translate that into the code required to be able to run that robot. So we're also leveraging that Copilot functionality, again, for the ease of use aspects of robotic programming moving forward. So now what I'd like to do is I'd like to transfer things over here to Chad Dukart. He's going to go ahead and show you the processes of acquisition of the software tools, and how quickly we can get a simulation running in the new iiQWorks environment. So now I'll hand it over to Chad.
Thank you for the introduction and the start. So the first thing we have to do is we need to download some software, and you'll see here the iiQKA address. iiQKA.com, and we go to software, and then we go to the robot system and the iiQWorks. And we need to download the sim or the other one. If we go to downloads here, you'll see the cockpit program. So that's our main, think of like a fighter jet has a cockpit, and that cockpit allow us to do lots of different things. And you can download that, and I'll show in a bit here what that software looks like. The sim you can also download, but probably not necessary. You'll get a later version in the cockpit program. So move over to the cockpit program. So the magic of installing it very quickly. And then we have a repository down at the bottom. And this will come up, and there'll be a box here. It probably won't show it on my system, but this box will have the iiQKA login or the AAD. And for internal people, we picked the AAD for Azure, but this has got all the latest software. Fantastic repository. Everything is here, all the different versions. This is just so awesome. I love this part of it. So now we're looking for, we're going to look for the SIM program. So I changed the alphabetical order here, and we're looking for the Kuka SIM, and we'll get the latest version. And if I find it in the list, definitely want to sort by the alphabet. And if we go on to the right here, you'll see the download, and we can go to the details, and we can see pretty much every version that's been around. So lots of versions already. So new software, but we've taken it through the paces already. So we go back to the repository. So we've downloaded the latest version of SIM because we'll need Cockpit and SIM. And then we'll need to download the Kuka KSS, Kuka system software, and you'll see it right down here. There it is. Finally, there it is. Yep. And we'll go to the right, and then you would download that. So latest version is 9.14, and you can see we've been through a couple different versions. We go back to our repository, and then the other thing that we're going to need is we're going to need to see the HMI. So we're going to find those two files, and we'll need this more on the when we do the VRC, or the virtual robot controller. So we'll download those two. And the next thing we'll do is we've installed the SIM, we've downloaded it, and we'll install the SIM, and you'll see that come up here in just a minute. Sorry, we need to talk about the controller manager. This allows us to go out to many machines. We might have one, we might have multiple machines, but what I'm showing here is the local instance, and that's what's running on my machine today. So the great thing about the digital twin is we can have a virtual environment on my laptop. We used to call this an office PC, but now we have the instance management. So each of these instances, think of them as like Docker containers, and we can have various versions of the software, KSS, and also the different packages. So this is the Kuka SIM package here, and I'm running the advanced version. There's a basic program, a basic one that's just a free one. And if I double click on that robot there, that robot is a KR10 R1100-2. It's a 10 kilogram machine with 1100 millimeter reach. And we'll zoom in a little bit here so we can see our robot. And we want to move it up a little bit. It's sitting flat on the ground, so we want a 500 millimeter riser. So it's moved up now. And we're going to turn it 90 degrees. And we're also going to place a conveyor in here next. So we need minus 90 degrees, I think. And we can use this little turner here that turns it. And if we click on that, you'll get even increments. So it should go to 90 degrees. There we go. Got it at 90. So next thing we'll find in our library there is conveyor. And we're going to use this batch conveyor. We want to move a box on our conveyor, and we want to place it someplace. So that's going to be our task for today. So we put the batch conveyor in, and this is a parametric conveyor, so we can change some things around. My cell doesn't require a 2 meter length. I want just 1,000 millimeters or 1 meter, and it's a little bit wide. We also need one box to appear, and we're going to have a width of 300 millimeters here. And let's see, what else do we need to do? We want, instead of a roller conveyor, we want a belt conveyor, because we don't want our box to fall through or move too much on the conveyor. And then we want to place it in a certain location. We've got axis bars to do this, or we can just type the number in directly. If we don't like the location, we can click on the X, Y, or Z and zero it out. Okay, so next thing is we're going to put a stopper in there, and that stopper, we're going to have it stop around, I think 700 millimeters will be good. And the next thing is we're going to zoom in here a little bit. And maybe make the stopper height a little bit higher. So we got 100 millimeters. We're going to have a box size of 100 by 100 by 100. And now we're going to attach, we're going to take the signal that says the box is present, and we're going to have that go to input number 1. So we can look at that input. in the simulation, and later on we'll do it in the VRC. Okay, and we need a creator there to create a box for us because we have a flat conveyor. We need a box to be created. So that's what this advanced conveyor creator does. And there's 5 products in here. I think we only need 1 today, so we will find the. I think it's on the next tab. There's product dimensions. So we have one. We have 1 box. We need 1 box, not 5 different products. There it is. And our dimensions will be 100 by 100 by 100, just a square plain box. And then we need to attach that creator to the conveyor so that it will display a box for us. So that PNP stands for plug and play, and it's dropped there, but the width I don't think is quite right. So let's make the width of that creator 300, just like the conveyor. And you see the blue bar that appeared, and now it is attached. So we should be able to create a box. And now we want to move on to write a simple program. And I think we got to go to the program tab for that. Yes, the program. And we got to click on our robot to display our robot program. And it always defaults to the main program, and it's got a home and a home. And we're going to just move our axis 5 down a little bit so we're not in the singularity position. And we're going to put in a 90 on axis 5. So we can just grab that blue bar there and move down. And on the right side, there's always a degree increment that's an even number. So if we click on it again and move down, it'll move in even increments, which is a handy feature. So we'll go down to 700 millimeters. And then it's got this great little bar here that allows us to have an overlay menu. So that should have, when we press that button, it should teach a point for us. So it's going to teach a point to point. And okay, sorry, we're going to touch up the home position first. So that position is now taught. And we're going to add a loop in here. We want the program to continually loop over and over for us. So we're going to drag the home position down there, and I think we can just delete that extra home. We don't need that. So now the next thing is we're going to move down, and we're going to teach. We're going to generate our box first. Let's try that. Okay, so we have 1 box that moved out. It stopped at the stopper, and it'll have another box, but only 1 box on the conveyor. I think we told it only 1 box. So we continue forward here, and the next thing we need to do is teach some points. We can jog the robot with the axis markers, or we can just grab it. There's several ways to teach points. And we can use the marker there, or we can also grab the little pink circle. This will also move it down, and it can snap this to this box automatically. All right, so the program is now stopped, and we can grab that little circle that's there, and we can, let me get in a little closer. If I grab that circle, and it'll snap right to that box. So it should be snapped to that box. And now I'll use this handy teach overlay menu. Sometimes that turns on and off, so you have to use the menu items to turn that on and off. And then we can jog up and down. So we'll have an approach position, and we'll teach that point, and there created the P2 point. And you can just manually grab those and move those wherever you like. So if I want it to go to P2, the approach position, there's the approach position, and then the drop-off location. And then we got some handy menus here where I can put in commands. So the next thing I want to do is I want to turn the output on that picks up the box, and that happens to be output number 1. How convenient there, and I want to turn it to true. and I can just create some points here. I can change those points. I don't have to use the name P3 or P2. I can change them to approach position, drop off, pick up, whatever I like. Okay, so I'm just running through the program here and getting the right locations. And if I want to move it up and down manually, I use the blue buttons there, the blue guiding buttons, and I go to even number. So it went to 555 millimeters. And I can touch up this way or use the menu. And now I move the robot to the right after I've picked it up, and I want to move axis 1 to a negative 90 degrees. So it goes right to that position and then reposition it with the bar there. So I'm at 400 millimeters in the Z location. And I'll touch up that point and create a new one. And there's another point to point. And very easy to guide the robot and move it around in the digital world, the simulation world. And we'll teach a Lin point there this time, so you should see S-Lin. And I think maybe the easiest way here is to just copy that output that's there. We can right-click on it and copy it, right-click again and paste it. And now we have output, and we need to change that to be output equals false, because we want to turn off that output and drop the box. You can see how easy it is to kind of guide the robot around and go to the different positions. You click on the position, the robot moves. So we're going to teach another point here for an approach position. And something else that I think we're going to want to do is we're going to add a wait sec here, because we want to wait a little bit of time to drop our box. Maybe 250 milliseconds should be good. So we'll put that in there. And then again, we'll copy the point and we're going to paste it, because I want to do the same thing when I drop the box. So we're on point 6 here. I think we can probably try to run our program. So we'll reset it. And then we'll press play, and the box should be there. We'll just cycle through our program. Did we miss anything? Okay, we're starting to switch to the VRC mode, the virtual robot controller. And to do that, we have to pick our machine. If this was a real machine, we would pick that, but we're going to use our virtual world. And we're going to start with the grasp and release instance, and we're going to send this to my local host or my local virtual machine. And we need to add those options, and those options were the user interface. So we need to find that in the list here. So available options. We have many, and we're going to add the UI. And then after this, we're going to add the UI operator. So we'll go find that. And when we have these two options in here, this will allow us to see the pendant in a virtual in a HMI in a browser. So we'll add that second one. And we should be able to reset our controller and press the play button. So we're going to press play here. And it's going to go ahead and download this to my virtual machine. I need to save the file. This VCMX file here is everything that's in our project. So once I save that, it'll continue to download down to the controller. So that's what's happening right now. And we're just going to jump forward here a little bit and not waste the time. And what should be happening is our virtual machine should be starting. The grasp and release instance should be starting here, and it's went blue, and then it will actually go green when it started. And you see that it changed state to green, and this should finish the download to the controller. Okay, our our VRC is downloaded, and right now the robot is running and it's waiting. And the reason it's waiting is we're in the VRC mode, and it's waiting for input number 1. And you see the yellow bar on the left side here, and you also saw the bar waiting. So what we need to do is we need to simulate the inputs. Okay, so the robot's running in auto, and we don't have control here. Our simulation has control. So we have this feature called SPOC, which stands for single point of control. And now I pause the program, so it should be paused here. And I can't force any inputs because I don't have control right now. So I'm going to request control. I do have control now, and I'll switch to T1. And now I should be able to. I need to make sure that I'm in an administrator mode to force the inputs. So I'm in an administrator, and now I can force the inputs, and the program is paused. And because I have control, I can start it from my pendant. So this is really handy that I can do this and go back between the simulation and the digital or virtual world. So now I'm in auto, and I started from my pendant, and magically it just starts back up, and it should run from my pendant. So really handy that I have a virtual pendant here and can do these types of things. Now I'll release control, and I'll go back to the simulation, and I'll press play, and the robot should run again. And also on the pendant, we can see that it's virtually running and working, and we should be able to see a view of that. We won't see the equipment because this is some overhead, but we definitely should see the robot, and I'll try to turn that robot so that it's the same orientation as we see in the simulation. So I can virtually do this on the pendant. Fantastic feature that I can do that, and they should move pretty close. They're pretty close. And I think that is the last part of what I wanted to show on the digital twin. Rich, I will leave it back to you.
Thanks, Chad. One last topic that I did want to cover. I talked earlier about your traditional controls engineers also having capabilities in the robotics world based on their previous knowledge of programming, say standard PLCs that are available in the market. And one of the functionalities that Kuka offers is a package called MX Automation. And what that allows you to do is a minimal configuration would be done on the hardware of the robot, but you're actually doing your robot programming, your moves, move coordination and things like that are all going to be programmed in the PLC. So MX Automation is actually a PLC block library that would be used with your PLC manufacturer of choice. As you can see, all kind of the larger names that you typically see in the market are listed here. So now, as a PLC programmer, I can program what I need that robot to do and when to do it, as opposed to needing to necessarily know how to write Kuka robotic language or have to use in depth the actual robot programming tools. Another technology that we see up and coming is SRCI, which is standardized robot command interface, which actually then the PLC manufacturers write the block libraries, and then inside of our controller we would actually put the SRCI interpreter. So again, leveraging that PLC programming knowledge to be able to also commission and program robots. So just to kind of wrap up, a few kind of key takeaways is to leverage robotics for flexibility and quick line changeovers. You're not needing to make mechanical changes. You might do a tool change. You might do a quick program change or flipping between multiple programs in a robot. Very, very quick and easy to do. Digital twin technology is the key to efficient deployment and change management. So instead of taking that line down, instead of waiting till I have the hardware in front of me, take the time to create and engineer that digital twin so that you can make everything kind of easier on yourself during the startup, and then also the change management later on. Make sure your tool set has the ability to support the digital twin functionality. Can it do offline programming? Can it do the digital twin? Can it connect to the outside world? Can it connect to those automation systems to get the information that's happening in the PLC so that you can operate in coordination with the complete system? And then also, as I mentioned, be sure to evaluate your complete risk situation as opposed to just a strict ROI calculation. Make sure you take all of the risk factors into account with regards to labor, with regards to total cost of ownership, and make sure you have a good, clear picture on that ROI discussion. So thank you very much for your time. That kind of wraps up the content that I had to present. Are there any questions that we need to review?
Thank you very much for that excellent presentation, Chad and Rich. So at this point, we'll proceed to the Q&A portion of the program. So those of you in the audience, if you haven't already, please click on the chat, type in your question, and click submit. We've received a lot of great questions already, so we'll just dive right in. The first one here, you had mentioned AI technology and the respective partnerships. AI in manufacturing has been talked about for some time, but we're just now starting to see more widespread rollout of applications. So what has changed with AI technology that has caused this ramp up of deployment?
Yeah, so what we've seen is if I go back, 5, 6, 7 years, we actually started to see the desire for AI in manufacturing, and actually at that time I worked for Siemens as an automation manufacturer, and we released to market the first neural processing unit module that would go into a PLC rack. And one of the challenges that the application engineers found with deploying that was that the data sets were just never complete enough. And so what we've got, what we didn't have back then that we have now is the ability to generate synthetic data sets for these AI systems. So now we can take that smaller data set that we have, we can run that through existing tool sets to synthesize and create a much larger, more complete data set. And then also NVIDIA offers the tools for the modeling and simulation of that situation, and now we've just got a much more complete view and data set for the correct solution to deploy to the field.
All right, that's great. It's interesting to see advancements like that and what you can do with that extra data. So the next one here, how do you approach applying robots in primary food packaging applications, considering the hygienic and environmental requirements?
Yeah, absolutely. That's actually, I think that's almost a webinar in and of itself to talk about the environment for food and beverage manufacturing. But I kind of look at it in a couple different ways. First of all, when you're doing primary food handling, you have to make sure that you don't have any kind of dangerous chemicals, greases, oils that are involved. So Kuka offers a complete hygienic oil version of several of our robots, for the portfolio, so that if we have a situation where there is, for some reason, a leak, we're not putting any kind of dangerous things into the food that it's handling. So HO is kind of the first thing, the hygienic oil version of the robots. The second thing is we get into a lot of discussions about wash down situations, and so those are always just kind of case by case. We have to discuss what are we washing down with, what kind of chemicals, what kind of temperatures, because there are absolutely robots that can handle that situation, and there are robots that cannot. So we always have to take a look at those two things. Primary food handling, we got to make sure that it's safe from a chemicals perspective, and then wash down, we got to make sure that the robot can handle the environment that it needs to withstand for the wash down situation.
Right, that's interesting. Thanks for explaining. Another one here, what are the PC performance requirements for the iiQWorks software and virtual robot controller?
Yeah, so I would need to do some research with regards to the exact recommended specs of the engineering PC. But one thing that I can tell you is, compared to some automation software that I've worked with in the past, there's reasonably low overhead with regards to these tool sets. I have your typical business office laptop, and I am running iiQWorks. I'm running the simulations. I'm running the virtual robot controller, and everything is working just fine.
All right, that's great. And then one more here. What is the cost of the programming software?
So if you're using iiQWorks for configuration and simulation, the basic simulation functionalities, those are free of charge. The website that Chad went to show the download of that software and those components, those things can be downloaded free of charge and tested without any kind of licensing. We do have some advanced functionalities that are licensed, but to kind of get the ball rolling and kick the tires, no charge.
All right, that's great to hear. Okay, so we're just about out of time. So again, thank you to Chad and Rich, and also thanks to our sponsors at Kuka Robotics. But mostly thanks to all of you in the audience for your participation today. For those of you who have asked, you can find materials from today's event and all Packaging World webinars archived at www.packworld.com/webinars. Thanks once more to our attendees around the world. We invite you to join us again on Tuesday,
Making automation easier.